Good morning, class. I hope you can see the screen. Can you see the screen clearly? Multisim combination logic circuits. Okay, that's fine. Good. So, right, class, today we are going to do these tasks. As you can see on your screen, we will use multisim to develop combination logic circuits. There will be two sessions. First one will be to develop combination logic circuits using IDC and SPDT switches. So what is this IDC? IDC is independent digital constant and SPDT is single pole double throw switches. So in the second session, we will use multisim logic converter, which is a very useful tool, and we can perform all of these functions, which you can see below. So in our previous sessions, we have created a combination logic circuit by using the expression and vice versa. By looking at the logic circuit, you have developed logic expression, truth table, and you have played around all these three things manually. Now we will develop all these things with the help of multisim. We will use uh, a very efficient tool which is called logic converter to perform all these functions. You can do it manually as we learned in our previous session, but you can do it very quickly by using multisim logic converter. So coming to the uh, first topic, before I start, I would like to inform you that this session is important because you have to use all these tools, multisim and the tools inside it to develop combination logic circuits for your assessment too, which is a practical assessment. And as we cannot go in our labs to perform the practical and projects, so we have to use this online tool. And multisim is very powerful and useful software, and you can develop any kind of circuit and simulation. So you have to do this work on multisim and take screenshots for assessment too. So I will
Yeah, Mr. Just one question. This is the first time we were doing a task on multisim, right?
uh, I think you did it before or not.
No, we have used it before, yes, but like in this course, I mean, in this course,
Yeah, in this course, yes. Yeah.
this is the first time using it with you.
Yeah, last week I just gave a quick demonstration to develop the. I think I showed you a couple of demonstrations before on basic logic gates and their behavior.
Mm-hmm.
And today I will uh, go with the combination logic circuits, how to develop combination logic circuits, and how to see their behavior, and vice versa. So we will start quickly. Okay, so first of all, you can see the multisim screen. Is it available to you guys?
This is shown.
Okay, so I have different circuits available here. I will first open the combination logic circuit, which is made with the help of single pole double throw switches. This is the switch actually. Okay, so this is one switch and this is the second switch. Okay, you can see the switch movement. So I will first run this so that you can how does it behave. You'll see there are three gates in this circuit, one NAND gate, one XOR gate, and another XOR gate. There are two XOR gates, so they are combined together in a logic circuit. And there are three LEDs you can see on top. These are the three LEDs. A1 B1 refers to input A and B, and F is the output. So if I start the simulation, First of all, you can see the position of switch A and switch B, which is referring to input A and input B. They are at low position, and you can change the position of the switch by either clicking on it or by using the key A. So I will run the simulation. So at this stage, when both the inputs are low, the output is also low. Second, in the second option, I will just make the input A high, and you can see that A is high and output is also high. Now I will make input B as high. So you can see that B is high and output is also high. Now if I make both the inputs high, you can see both the LEDs are lit now. The output is also high. So this is one basic example of a combination logic circuit. I will stop the simulation and I will draw this circuit again for you guys how to develop a circuit like this. So before that, as you can see, this is the MULTISIM interface. The top bar is the menu. Okay, you can see the file edit view. Like in any Microsoft application, uh, you used to have these options available. So you will see pretty much similar options in MULTISIM interface as well. Okay, so I will leave it on to you to explore what is in there. I will only focus on the important things which you need to develop the circuit. In the second bar, you will see the shortcuts relating to the top menu bar, like open file, new file, save, print, search. So all these things available here. And in this box, you will see all the equipment used in the circuit, all the components used in the circuit in use list. So it's a useful thing. If you want to make a bill of material about your circuit, you can just quickly have a look on this. Okay. The third bar is the shortcut to place different components. As you can see, if I hover on this icon, it says place source, place basic. These are the basically groupings which are available in MULTISIM. So all basic components will be under this icon. All diode related components will be under this icon. So, and there are so many different icons available here. From here you can, this is actually a shortcut. From here you can place the components quickly. On the right hand side, this is the instrument panel. Okay, it's the vertical menu bar, you can say. On the right hand side here you will find all the basic instruments and advanced instruments available here, like multisim, function generator, watt meter, oscilloscope, 4-channel oscilloscope, board plotter. So there are all the test instruments available, and you can just drag and drop here. These test instruments are available as a shortcut here. And the second option is, if you want to, the second route is to reach these test instruments is from simulate. In simulate, you will also see the run button. Once your circuit is complete, you can run it from here. And from here, the instruments, you can find all the instruments here. Okay. To place the components, you can, this is the icon here, place components. Okay. This is the place component window. Make sure the database is selected as master database all the time. In the groups, there are various groups. You have to, with practice, you will come to know what type of components are available. Source grouping, in basic grouping. For example, if I click basic grouping, the group is basic now, database, master database, group, basic, and there are further families inside that. So like, for example, resistor, the most common and basic component, capacitor, inductor. So when you click a resistor, you will see lots of resistors here with different values. Okay, if you don't want to scroll down, you can just click here and like this, and it will shortlist the required resistor for you, either 100 ohms, 100 kilo ohms, or 100 mega ohms. So you can type in any value here. Okay, now quickly going on to the new design. From file, new, you can click from here, or you can just simply click this blank page icon. I'm going to open a new design. I will develop the same circuit for you guys so that you know how to develop this. So first of all, we need three gates, which is one of them is NAND, and one XOR, one XNOR gate.
Teacher, specifically must be this kind of gates, or in future further
Could
it will
be
be like a
any
different
gate.
like kind gate. Okay, okay.
Yeah, you can make any combination you like, and
No, no, I'm
because
not
this
trying
was,
to be advanced, but like in future, maybe I don't know. Maybe you can ask us to do something different. Like, you can ask me,
yeah,
okay,
yeah,
Abdurrahman, make your own combination now.
yeah, yeah. I can ask you like that, or I can give you an expression, and you can develop combination logic gate based on that.
Hmm.
Okay, so let's go to the blank design and place component. Okay, and master database is selected in the group. I will go to the TTL because I told you before that TTL ICs we mostly use in our lab. So, okay, let's go in there and find we should have a NAND gate. So this is the NAND gate available. So I can press OK. Okay, so this small window is showing that it's basically in one IC, in one package. There are uh, four or sometimes six or sometimes eight gates available. So I will click just number A. So because I want to use the first gate. So U1 is the IC number. Okay. So it will, by default, it will show here. So you can see this 7400N is the IC number, and U1A, I'm using the first gate of that IC. Okay, then I need one XOR, one XNOR gate. Or if you want, you can place any other gate you like. So I will go for any gate. See, there is an icon place TTL. So instead of going from place component, you can directly go into the TTL. It will take you to the same window which we opened a while ago. Okay, so for example, this is the NOR gate. I press OK. Okay, I placed a NOR gate here. Again, I will place some more components from here. Let's say a NOT gate. A NOT gate I have placed.
Teacher, I'm sorry, I got really confused. Like, what's about the letters? Like when it's have A, B, C, what does it mean?
See, ABC, see, when you are using a NOT gate, you basically
Yes.
you will take an IC. That
Mm-hmm.
IC will have maybe 8 NOT gates built in that IC. So it's your option, your choice, which gate you want to use. So I'm just selecting the first one by default. Okay.
Oh, okay. But
Yeah.
I mean, by the letters, it
Yeah.
means something.
Even
The
if you
letter.
use B, C, or D, it doesn't matter. It will do the same function as you can see. It will bring out some not some gate which you want.
Okay.
All right. So let's do one more TTL. Okay, this is AND gate. I will place an AND gate here. Okay. So I hope that's enough. I can make a combination logic circuit based on these four gates. Now I need inputs. For inputs, there are two ways. One way is to use a single pole double throw switches. So I can go to the components. Okay, I went to basic group and I see there is a switch option here. I need to have a single pole double throw switch. So SPDT is available here, single pole double throw switch. This is the symbol you can see. There are more information available. Function is written here. Its model manufacturer ID is written here. Footprint is written here. Footprint manufacturer type you need mostly when you are developing a PCB and you want to know what type of design and footprint this component will have on PCB. So I will just click OK and bring this component here. Now this component, I will rotate it horizontally, flip horizontally. Why I'm doing so? Because from here I will bring up high input on this line and I will bring up low input on this line. And from here it will go on to the gate. Now I need, because it's a two input logic circuit, so I will need one more single pole double throw switch like that. What I can do, I can simply highlight, select this component and use Control C, Control V like you do in Word to copy paste. So there is one more available now, so I can just put it here. Okay. So now what I need source. I will move the whole circuit a bit to the right. I need a source, VCC or 5 volt you can say, and a ground. So again I will go to either from place components or from the basic. I will go and I will go into the sources. Okay, and I will look for the digital sources because I'm dealing with digital. Uh, sorry, I will go into the power sources. So in the power sources, I will go for VCC. Okay, and I will put VCC on top here. And I will place a ground there. Okay, ground is there now. Okay, now I will make connections. So this switch, you can click on this and you can change its properties. For example, you can change the label. You can write as input A and you can key for toggle means if you don't want to click on the screen for changing its position, you can just use keys to change its position. Let's say I for input A, I choose key A to change its position from high to low or low to high. I press OK. So you can see that its property has changed. Now the same I will do for input B. I will key for toggle. I will put it as B from the value option, and from the label option I will just put it as B. I will press OK. These two have changed now. So let's say input A is going into this through the inverter and going into this NAND gate. Okay, and input D, let's say is going into like this to this gate. So this gate connection I have made. Making connection is very easy. You just need to bring your mouse to this point. It will change its shape like a cross here, and then you click it and then drag the mouse where you want to draw the line, and when you reach the next point it will again change into a crosshair. You click one more time and the wire will be connection will be established between those 2 points. So it's simple like that. Okay, so I have made connection for this gate, NAND gate, which is on the top, and I have given its output to this final gate, which is NOR gate. And this gate, it also needs two input A and B. So let's say if I take input A from here before the NOT gate, okay, and input B, I take it from here, this line, which is input B. So that will do my circuit. Okay, so I have established this circuit now. Now I need to supply the input to this A and B. How can I do that? Remember, there are two positions, high position, low position. The high position should go to the VCC, which is 5 volts. Low position should go to the ground. So I will put this and take it to the VCC. Same I will do for the switch B. Okay, and the low positions I will take it to the ground. Okay, now the circuit is made. I need some indicators to show when the input is high or when it is low. How can I do that? I will place components and I will go in the indicators. You can see the group indicators here. Okay, in the indicators I will go in some probe. Probe is a LED which you can see right here, probe digital blue. So I will use one blue LED for, you can say, input A, and I will place one, let's say, or red for input B, and I will place the green one for the output. Okay, I will close all. I will make connections now. So this first one should go in input A. This is the line for input, and line for input B is here, this one. Okay, so now the circuit is complete. We should now test it by running it. Both the inputs are at high, so we can make it low. Okay, either by clicking on this or by the key. The key A is controlling the input A. Key B is controlling input B. You can see that. So I will run the simulation from this play button. You can run it from here or you can run it from this button on the top right corner. This is also there. So if I run it and I see the output is low because the both inputs A and B are low. Let's make one input high. So now A is high, but output is still low. Now I will make input B as high. When the input B is high, you can see this B is high, A is low, and the output is also high. Now when I will make both the inputs high, you can see both the inputs A and B are high, but the output is low. So that's how you can develop a combination logic circuit using multisim. And with these LEDs, you can understand what is the status of input A and B. Okay, instead of looking at the switch, you can just quickly look at the LEDs, and then you can uh, make a truth table. You can take a pen and pencil, you can write down quickly the combination, input combinations and the output. Okay,
Teacher, when it's turning on is 1.
yes, when the light is on, it means it is a high
1.
level. High level means
Oh,
one, binary one. Yes.
uh-huh.
Okay, I will stop this simulation now and I will quickly tell you one more. See, here we use switches A and B for the input. There is one more option available in multisim, which is called independent digital constant. So let me use that. What I will do, I will just delete this part. The remaining circuit will stay as the same, but just I will delete this part. Okay, now I will bring that place component. I will go into the sources. I will go into the digital sources. Here you will find three things: digital clock, digital constant, and interactive digital constant. This is what I'm talking about, interactive digital constant. So digital clock is just providing a pulse. You can set its frequency. It will give you alternate inputs between high and low at a certain frequency. So it will keep on changing like a clock, high, low. You can see this rectangular wave as well. Digital constant uh, is it is giving you either high input or low input. It can only give one of that. Interactive digital constant can give you both types of inputs, high and low, 0 and 1. So I will use this here. Okay, I will use one more here, right? And then I will close. So this will go in there and this will go in there. This is A, this is B. Again, you can change its label from here if you want to write A, and this is input B. So I have changed the labels. The key, you can also change the key. Okay, from the value option, go for key for toggle. For input A, I'm selecting key A. For input B, I'm selecting key B. Okay, now I will run the simulation again. Okay, now it is running. You can see that the play button has gone gray. It means the simulation is running at the moment, and this is the stop button which has turned into red. So now at the moment, both the inputs are low, and you can see the value is 0 from here, from both of them. So let's make one of the input high. Let's say I'm making input A as high. I just pressed the key A from my computer, and you can see the 1 is written here. This is high, but the output is low. B is still low. So second option, I should go for B as high. Rather, it is the third one actually. So B as high, you can see it has changed its value to 1. A is low, B is high, output is high. And fourth option is to make both the inputs high, and now you can see both the inputs are high, but the output is low. So that's how you can make a combination logic circuit, and you have an option how you want to provide the input, either by using interactive digital constant or by using SPDT switches. So I will stop this simulation now. Any questions, guys, on this?
No, it's until now basic.
Yeah,
Very
good.
simple.
Okay, so next session we will discuss about the logic converter, which is more advanced and more useful tool. So I will stop this recording now and we will start the next session after 5 minutes. Thank you.